Actually, I have a bone to pick with cancer because cancer killed my grandfather. He was 89 and he was going strong. He got colorectal cancer and died within 4 months. So it's kind of a personal motivation to get at the bastard. So this particular patent is explaining how we can use microfluidics, this capability of working with really small volumes and controlling really small volumes on a chip, so that we can use a biochemical method to assign, if you will, a coordinate system for each one of those little boxes and inscribe that coordinate system inside the DNA that is being generated during polymerase chain reaction. So you can think of it as we take a tiny little pencil and we write down the coordinates just on the exact piece of DNA that later will be analyzed by high throughput DNA sequencing techniques. This way we have an enormous amount more information that we can extract because of these coordinates inside the particular piece of DNA. And then the advantage is that we can just rip up the entire chip after this is done and collect all the DNA. And then as we read out the sequences, we can tell how many of them there are and where they came from. We can, let's say, determine what is the concurrence of different mutations, where they happen. Do they happen in normal tissue or do they happen only in cancer? We can correlate a very deep biochemical information. I think that it is a possibility, at least, to think about what kind of biotech can be developed here. At least 2 of my students have expressed potential interest in going to medical school using their GI Bill. One of the things that potentially to consider is to have some kind of an offshoot of applied physics towards bioengineering at a certain point, because that would allow students to maybe have some kind of a subspecialty or something like that, or at least potentially work on projects like that, because there is definitely interest. It's just a matter of figuring out how this can be done.